All right. Hey, everybody. Welcome to another TopoDOT webinar series presentation. I'm going to help you today navigate the opportunities available within the distribution corridors. I'm Mike, and I'm the lead applications engineer over at TopoDOT. I've been here 10 plus years, and I've got medals to prove it. And I work with the support, development, and sales team, and I'm not alone. We have a dedicated team to help support the TopoDOT community. We're a software development company, but we also provide training, support, and consulting services. To kick things off, for the first timers out there, TopoDOT is a industry-leading software application for extracting high-quality topographies, 3D models, assets from your point cloud data. This all feeds downstream operations across multiple disciplines. The primary application areas for TopoDOT is going to include transportation corridors with rail and roadway, electric and power corridors for transmission, distribution, and substations, as well as bridges, tunnels, and general structures. Our focus today will revolve around strategies for extracting power lines and utility poles. First, a quick look at our agenda. We're going to have a brief overview of what's to come. We'll be talking about three main workflows and some companion tools to consider moving forward, as well as some tips and what else are we going to be looking forward to in 2021. All right, so there is quite a bit of stuff out there, and I've heard a few times before that the electrical grid is one of the largest machines on Earth. So there should be plenty of opportunity out there for doing any type of work on this infrastructure. And as long as the features are large enough and no smaller than the spacing of the data points and or the pixels of an image, we'll be able to extract the majority of these items seen here. And what are these features that I'm talking about? This is a quick list of what you can extract, which includes towers, poles, wires and attachments, clearances, real estate on or between the power and communication space, encroachments, sag points, footers, etc. The majority of the larger objects are going to be extracted using the point cloud data alone. And for the smaller objects, these can be identified using both the point cloud and the imagery, particularly a high-res image from the system. We'll see one of these images in a moment. And there's a variety of tools and workflows to pick from, when you're extracting this information, and we'd like to set you on the right path today, particularly about power lines. All right, so a close look at the data here. This is mobile data. It's, in this case, a single pass dual head scanner configuration. So there's plenty of detail. And, we're looking at two elevation views of a shared pole with those high-res images that I just mentioned. And the point cloud here happens to be colorized in elevation. So generally, MLS and TLS or any terrestrial data is going to be better quality, more detail than an airborne system, which is going to be necessary in order to extract what we see here today, or most of it, as well as all the features mentioned in the previous slide. But with that said, airborne data still plays a role when focusing on larger features, specifically transmission lines. In this example, all the data was done outside of the substation. So we're going to cover three topics here. There's no need to shut things down, saving time and money. The substations themselves are usually the hardest to extract. They have a variety of equipment and structures, a variety of wire lengths and paths, and everything's packed into close quarters here. The tooling is going to be limited to semi-automation for wires and attachment points and or vertical objects. But the key is to have user-friendly tools to allow for optimal interaction with the cloud and imagery. For example, easy navigation, cross sections, being able to snap to points, loading your images, etc. So this is just kind of a quick look at what you can do and what you can accomplish with the current tool sets within TopoDOT. Here's an example of transmission lines. They're generally the easiest to extract and collect. This is usually collected with airborne systems or drones, but you can also do it with mobile as well. You just got to find a driving path. But they're easy because they're isolated and spaced out. They have consistent wire structures with little change, and they're fairly linear in nature. Automation routines can usually handle most of the transmission line projects. When it comes to distribution lines, they're a bit more challenging and require more detail, which makes mobile data the ideal system for this. It's challenging because they're surrounded by their features and trees. They have inconsistent wire patterns, complex wire routes and paths. The poles are all staggered. You can have different tiers. We'll see some of that later. So use automation where you can, and then finalize with the necessary semi-automated tools. And we're all about productivity, and it's important to understand the balance between automation and user input. We see, there's more value in user-friendly tooling than there is in hands-off automation. Well-defined workflows and these user-friendly tools is going to allow any team to produce and scale effectively. When it comes to exports of all this data that we just saw, or all the extraction work, you have attribution that you can export into a shapefile, CSV, KML, or JSON. This is if you're going to like Esri, Autodesk, or Bentley, or any other location receiving attribution. You can export your fully modeled wires and poles into a variety of supported CAD formats. If you want to go into like a loading analysis software for your communication space and distribution lines. Or if you're just simply exporting your classification information, that's just a point cloud creation there. If you're going to PLS CAD. And then there's also sheet extraction. This is just get your tower into a drawing sheet for quick markup and printing. Throw in dimensional elements in there. It's usually pretty easy. All right, so depending on what you need, this is where we're going to get into the methods here and the 3 demonstrations that we'll be conducting. So depending on what you need, we'll basically recommend that path. And hopefully this table here can give you a sense of which path you'd be taking. So we'll be jumping into each one, and there's a lot of tools. This is to help you decide on that path. And as an example, let's say you're looking to do full attribution, and you're getting poles and tilt and the works. Okay, and it's very complex. Your path would most likely be number 2. Okay, if you are tasked to just get poles, like the base of the pole and maybe some attribution, and you guys aren't worried about attachment points or classification or anything like that, then number 3 will work out just fine. Okay, and if so, keep in mind this presentation is going to be available for download on our university page later, so definitely keep this in mind moving forward. And if you have trouble, I said this before, but please contact us. You want to establish the correct path, okay? This is going to help you reduce any duplicate work, ultimately saving time and cost. And you're going to end up with a cleaner drawing export, for the most part. And this is also to help identify room for any additional value that you want to pull out of your point cloud, because you might be doing a topo project, and at the same time you have Powerline information there that you can also exploit. All right, so real quickly, this is just a glance at method 1, and for those of you who are familiar with the transmission space, the idea is that we are gathering the towers first. So you're essentially creating a tower string. Okay, there's obviously a little bit of prep work involved with the data. It's recommended, but the core of it is locating those towers, whether it's automatically or you're clicking on the towers, and then you go into a wire extraction routine, which is fairly automated for transmission lines. From this, once you get your lines, then you can go into classification routines. Okay, you can classify off the wires, you can classify off the tower string. There's a couple of ways you can do encroachments. And then when it comes to exporting, most likely you'll be exporting the point cloud if you're carrying that classification forward. If you're just carrying the elements forward, there's really no attribution a part of them, so they're just basically elements at that point, which you could use a feature code export or create a DWG or DXF or even a KML. Okay. Any attribution done here would have to be done post. The other two methods have attribution during the process. So let's take a look at this in action. And this is what we're going to tackle. Very simple, standalone poles. The wire configuration is consistent. There's not a lot of interruptions. We're going to consider this a transmission line. Okay, there's a variety of transmission lines out there, but this is a very simple, straightforward one. All right, first we want to prep the data a little bit, which you take advantage of the classification routines to hide the ground and get the above ground wires to really stand out. And as I go through this, I'm going to be showing you every single tool location and which tool I use. So you can treat this as a tutorial too. So what I have to do first before I search for the towers is I have to set up a guideline, and this could be at some relative elevation, doesn't have to be perfect, but it's a line for the searching routine to occur. So the next tool that we're going to see is going to piggyback off this line. And that's going to be the locate tower by template. And what we'll do is we'll just look at the side of it, get some measurements, and then we'll plug that information into our height tolerance. So we're looking for a specific height, plus or minus, and then we want to set our sample box appropriate to that. If you know that you're going to get leaning towers, make it a little bit bigger. Okay, tune the tool for the towers that you're searching for, and once you hit process, it's going to find all those towers for you. Now you still want to check this in case it's missing any towers or it's picked like another pole that's not a part of the strings. So I'll show you this. You basically just click on the top of one of the towers. Now keep in mind, I believe I should have kept the ground on in this case before running the routine. So you may not get as many towers as I have missing here, but for the most part, all of them will be found for you if you have that ground on. So that's just a quick check. Gives you an idea of how to add and subtract. You click on a dot if you want to subtract one. this information is going to be passed on to the tower manager, which you could use to inspect the towers, but my primary focus here is just to get the wires out and the attachment points. Okay, so you could skip there. You could draw your tower string and take advantage of that later, which you'll see. Okay, that tower string is basically just at the tops. You could drape that, get some ground information too. All right, so the next step is now getting the wires. Now that we have all the tower locations, we know where all the spans are, so we know where to go. Okay, so you set up your template. And what this will do is it's basically going to just match those points to those clusters of wires there. Okay, we're looking at a cross section before and after all the towers. I just hit the auto button, and that basically is going to go through and automatically match those that template to my wires. And if the configuration changes on you, it'll ask you to stop and fix it. Okay, so you just push the points around and accept that. Okay, it's getting the spans and it's also getting the attachment points for us in one go on this tool. There's a quick glance at our work. Here's a close-up of the attachment point. Okay, you can see this is a fairly straightforward, easy process. You could scale it up to larger towers. It obviously works on the smaller towers. It's a very useful tool. All right, so now I'm going to be going into classification. If you notice, I selected my conductor wires, but I only selected the B-spline ones. This is just in the span. Okay, the reason for that is some of these wires kind of float around a little bit. They're a little bit fuzzier within the span. So I'm increasing my search radius for those wires. Okay, the next step is to grab the conductor wires that are where my attachment points are, and I'm going to fine tune that value so that I'm not searching too far. I don't want to bleed into the insulation points. Okay, I don't want it to bleed into the tower. And I'm trying to reduce cleanup. So again, I'll select my conductors and shield wires, switch to just line strings so that where the attachment points are, those are line strings. The spans are B-splines. Take advantage of that. Okay, I accidentally forgot the shield wires here, so we'll do the span one more time. And what's happening is it's looking at those elements, searching within a small radius to classify the wires, and then there's a larger radius for encroachment. If you're not worried about encroachment, you could just pick the same value as the first box. Okay, so we have the cross-sectional tool open now. And if I want to get into classifying the insulators and the tower, I could take advantage of that tower string path and just jump to the vertices. Okay, that would be basically jumping from one tower to the next. Okay, you might have to turn a couple things on and off to help with the process, but essentially you'll be using a classify inside fence approach. Drop a block down, drop a shape, and then there's the classify inside fence tool. Okay, so if you are in the business of classifying the data to this detail, this would be the way to do it. And there's a little trick there. I did modify fence and just add position. That just allows you to kind of recycle that shape for a small period of time. And now that I have the insulators, the ground is hidden right now, and I'm just going to throw all that remaining data into the tower. And you could probably hook up a couple of function keys to some of these commands instead of having to open up the modify fence. And you can also hook up the function keys to the classify inside fence too for quicker classification. And I didn't have the towers in this case, so if you're familiar with the tower tool itself, usually it has cylinders to work with, and you could take advantage of those. That's not something I used here, as I just wanted to kind of show you some exercises via this cross-section option. All right, so we can see that what's happening here is I'm throwing the wires into a specific class, the insulators, the towers, the grounds in a specific class. So you can either point that to a new file and create a new point cloud, or you could pass it to the original files to basically overwrite and assign this classification to those files. That way you're basically saving your work. If you're just exporting the information, we'll be using the feature code export tool. Okay, there's something in the options that I wanted to point out. It's the spline stroking distance is going to take all those B-splines and convert them into polylines with a specific defined segment length or count. And right now I'm in the auto tab, so what I want to do is identify all the levels that my work is on, and I'm going to point that to a specific feature code that I'd like. That way it's going to go through the entire project, and every time it encounters that level, it'll assign the correct feature code. And it's going to build my list for me. Definitely save those lists if you keep reusing them. Once you hit process, it's going to go through that whole project and build your temporary list. You go ahead and save that to a CSV, and there your information is in a compatible format for other operations. All right, so that was a quick run through on the transmission. Let's take a look at distributions now. And there's a little bit of prep work as well, so we kind of use the same technique of classifying the data and then hiding the ground. But we're going to focus on like one level at a time, because in this case I'm going to have a variety of levels. And the main difference between the first one that we just saw and this one is we're going to be extracting the spans first. So wires come first and then the towers. Okay. And so we're going to get those spans. We're going to then join the wires, create the attachment points, and then we're going to flow into the utility pole tool. All right, here's a quick visual of what we're about to encounter. So you can see the different tiers of wires that we have. The poles are at different staggered intervals, different heights. Sometimes the wires are crossing, they're dipping in and out. Shared poles, wire counts change. A lot of stuff is happening. Okay. So just like we did before, we're going to classify that data. I do measure just to give myself a gap here. That way I can toggle off the overhead wires from the lower wires. Okay, so take advantage of that. And I've taken preference on working on the bottom set first before going to the top side, just so that it's not in your line of sight. All right, so once that's isolated, then you can open up the newer tool, which is going to be the Powerline extraction by cross-section. And we'll have a variety of examples here. So if you missed the first run, don't worry, there's tons of them to come. But the idea is you just identify the span right in front of the tower, or just in front of the tower for both towers, and it will find those wires automatically for you. Okay, so this is a huge improvement to what we had before. We're getting a cross-section view. The tool is staying open so that we could just jump right into the next span. It's finding the points for us. It's connecting the right points to each other. We have a preview, an automatic preview. Okay, so this is dramatically faster than the original cross-section by, or Powerline extraction by cross-section. Now, once you start getting into the fun stuff, you're going to run into situations where you're going to have to look at these cross-sections a little bit closer. Okay, so you can adjust the points. All right, look at the numbering convention, look at the order, make sure the wires aren't crossing. In this case, I just decided to accept the wires and then just do a quick manual modification. Really easy. Don't spend too much time on it, and then move on to the next span. Okay, you can tweak the settings for your project. That's where we kind of come into play when you work with us. But if you have any trouble and it's only one wire, take advantage of the manual wire extraction or the approach that I just took. That dashed circle that we see, that's the auto snap zone. So it will only snap to the data within that circle. Okay. I'm also encountering another situation where maybe the wires are too close. So in this case, I'm just going to get rid of one of those, and I'm going to switch over to the manual extraction while I'm on this cross-section. So that's the benefit. You're kind of working with this main tool, and then you're working with these companion tools. Okay, so each span is now reduced to just a few seconds, and you can really knock out a lot of spans in a short amount of time. This one was perfect for me. If you want to be a little picky, again, here's just an example of how you do that auto snap and take advantage of that circle. Okay. You don't want to be snapping to like junk on the side or two sets of points. For the shorter spans or anything that doesn't seem to be behaving properly, you can always break it down to just one side at a time, like I'm doing here. That way it's easier to visually digest. There's not too many points to keep track of, keeping it simple. All right, it's just another technique that you can try. Okay, take advantage of that automation and take advantage of the user input aspect of it. Now I picked an area with wires being very close to each other just so I could show you the functionality of all this stuff. When you fine tune this and your wires are looking like this, you most likely won't have to do too much modification, but I want you to know that you have the flexibility of doing so in the first place. All right, so I switched over to my top wires now, and this one's pretty much a no-brainer. You almost don't have to check anything unless you don't define your cross-section wide enough, but you can almost even consider this kind of like the transmission lines. However, you'd have to go and find the towers first. But so if you get too close to a tower, in this case, just kind of back up a little bit. Okay, so now that all the spans are done, we can then focus on joining all these wires. So I'll just show you a couple of combinations of what you could do. You could technically just grab all the wires and let them join, but I'm going to join them in segments. Okay, so you can now do multiple wires Before it was just one wire at a time. Okay. All right, so we, in this case, I forgot a wire, so I could just easily open up the manual power line extraction, add that extra wire in, and then continue on with the joining of the wires. So for the most part, you could just use auto join if you have them selected. Okay. For the smaller, short runs, areas where you think could might need some visual checking, do as I do. But for the spans that look like this, most of them are catenary, long runs. You could probably just run it on the whole thing. All right, so we're getting those connection lines, and then we're also getting the points, just like we did earlier. These are the same lines, it's just a different approach. Now we can open up the utility pole tool. This is going to automatically detect the attachment points and basically help you search for that tower. So I'll be placing a cell down because I'm going to be including attribute information along the way. You do need a cell for that. Okay, and the idea is you just check your ground, set your radius, check your top. Okay, the information that you're seeing in these previews can be stored in the attribution on the right-hand side. You can see radius, tilt, and things like that, height. You'll see this at TB and at P1 symbol. Those are the actual attachment points. So those attachment points are automatically being detected and pulled into the space so that you can include that into your attribution if you like. There's a visual of a look at one of those towers that I just pulled out. Okay, you're also going to get relative measurements to each other, or you could do to the ground. It's an option. If you want to have that picture synced up, just go to your auto picture and set it to like view 3. And we're just going to go ahead and repeat a few more polls here. Okay, I have an ID counter. So just talking a little bit about the attribution there. So that's a counting feature that's just going to step up at a single integer. I'm adding a point here and naming it TB. And if you notice in the attribution, I have at TB. So if you have like a fuse or a transformer or anything you'd like to add, you can add that point in and pull the information from that point, as well as view it in the photo. Okay, in this case, we're tweaking the ground, taking advantage of both elevation views. Sometimes one will be better than the other. Okay. And it's pretty much straightforward from here. It's the same concept. Now, if you don't want to use the automated ones, let's say you just want to go to a random tower, you could still do that. It's not going to detect any attribution points or attachment points, but you can at least add them yourself. Okay, and I'm going from the bottom up just because that's when we identify the attachment points, we're going to be going from the bottom up, starting at 1, 2, and 3, and so on. So if that is your main focus, definitely start your points at the bottom for the communication space. Okay, when you move the axis of the tower, all the attachment points that you add in are going to stay put. So they have relative distances themselves. And then we'll take a look at this one more time. I've actually recycled the points from the previous tower here. So instead of adding them one at a time, you can also pull from your previous tower. It's kind of like just pulling that template over. And then there's obviously drop-down options too, which you could choose from. Okay, we'll see how a schema is built in a little bit. I do that for the asset ID one. But before we get there, this is the attribution that we've assigned. During the extraction here, we've assigned this attribution. You'll then export this information into either a shapefile or a CSV, okay, for those downstream operations. Okay, the attribution is going to be stored in the form of an item type. They used to be called tags, but you know, the naming convention for us and to understand it's still kind of the same. All right, so let's take a look at the next method. And this is going to be working with the asset ID tool. And for the most part, we only need the poles or any other vertical objects that are sticking up out of the ground. Okay. And it has active tagging. And we could do the same type of export that we just saw. And there's an auto feature on it to search for those towers. Okay. And of course, a little bit of prep work up front doesn't hurt, but not completely necessary. All right, so going back to our project here, in this case, I have it set to color by distance or elevation. And you can either fence an area, or in this case, I'm cropping just to narrow down the search field for the tool. And then you can go into your auto extraction and hit locate assets. I do point out that you do need cells. Okay, so if you're doing any attribution, you will need those cells, and you also need an attribution list. So let's take a look at how that's built. So this is our attribute schema. Right now I'm just building the attribute names. And then once you build the names, you can start adding the values. So that the values would be like the percent Rs, the percent tilt, percent age. That's the the syntax that we use. We have an extensive list on the wiki page if you're curious to know what else is workable. And if you need anything else, just kind of let us know. But for those first timers building an attribute scheme, I'll recommend to definitely plan it out before you start building this stuff, and then understand the differences between like double precision and strings and integers. Okay, so if you're storing a decimal number, you want it to be like a double precision. If it's just a name or like a type of something and it's going to be a user input, it could be a string. Okay. If you have the lat and long information in there, make sure you have a defined coordinate system too. If you don't have a defined coordinate system, you could just do X, Y, Z, like %X, %Y, and Z. There's that auto picture again, going to our view 3. Okay, and then we'll go ahead and just locate all those assets. Okay, so it just ripped down that entire corridor. It's going to identify all the objects that it's found for me. And at this point, it's just up to me to pick the right feature type, set the cell, and store the right information that I want to store with it. Okay, so that's just placing like a cell down and possibly a cylinder. If you want to focus on getting the tilt or anything like that, then you're going to want to have to modify the top. Maybe correct the height too. Okay, there's some standoff on the top of that, so the pole is a little bit shorter than the data there. Okay, always start with the ground first. There's an offset. Once it calculates the ground, it's going to do an offset up to calculate the trunk. That can be found in the options. Kind of like what we see with the little crosshair in the preview, but yeah, move the ground first, then adjust the top, set your attributes, and then hit accept. Going back to one of these, you can see that it places a cell and a cylinder for us. Okay, the cylinder options in the options tab. And then just a quick look at the properties. So each cell is going to get those properties. You have to have cells to store attribution. It could be from a cell library. You can create a generic cell, but it has to be used. And then for the most part, you just go through, accept, and skip what you need and don't need, and you're done. So it's pretty easy to get towers this way. And again, it's the same method as before. You can either go a shapefile or you can go CSV. In this case, I go CSV just to show you guys. And an optional feature code export. So if you're not really doing a lot of attribution and you just need to get like XYZ information of the cell at the base, the feature code export tool will be handy there for you. So it's just kind of to separate the tagging exports and the feature code export. The feature code export has a limited amount of data you can pull, while the tagging route has kind of an unlimited attribution. All right, so after those three methods, you can kind of intermix some things. Obviously after you get the wires, you can start talking about classification, which we saw a little bit previously. And these ones here deserve an honorable mention, which we'll see a few examples in a little bit. But for encroachment, the idea is you have wires that you've extracted and poles. You then use these to perform the automated encroachment routine, and essentially this will classify the data around the wires up to a specified distance. In this case, we have two zones to represent an inner and outer region. The inner region being yellow, the outer being red. And then if you classify the data, if you have it classified like this, you can then follow up with like a clearance to cluster routine, which will find the closest nearby objects. Okay, you'll be left with a geolocated dimensional element, which you can kind of see in top view. All right, what else can we do with this encroachment data? It's usually just a point cloud, and it has been classified into a specific class. You can either save this to an existing point cloud or export to a new one. We saw this earlier when saving the classified wires. But sometimes, delivering the point cloud is just too much data, or it's not going to be compatible with any downstream operations. So here we can see, thousands, if not millions, of classified encroachment points. So in this case, you'd consider a clustering routine, which is going to identify the clusters of data and then simply graphically outline them. So what you're left with is a simple shape element per cluster or object, and this can be seen in top view as the red elements. This ultimately keeps the file sizes down and becomes just more compatible with other platforms, since it's just a simple element. You can also assign attributes to these things too, and pull like area or volume, and then send this stuff to like Esri or Google Earth. Clearances are pretty straightforward. You can gather the lowest or the crown. And if there's any crossing wires, you can do measurements between those two. So if you have like a northbound and then like an eastbound set of wires, you can measure between those. Simply just select the wire of choice, and the tool's just going to automatically search the ground and give you that clearance. So you don't have to clean up the noise or the vegetation or anything like that, any floating points. The tool will mostly filter this out for you. And some key-ins. So we talked about the exporting of the tags earlier. If you're just looking to export a small selection of them, you can use the key-in at the top for either a CSV or shape. Because the tool that I showed you previously, that's just going to export everything that's been tagged in the project. But if you want to export a handful of items, you could do so with those key-ins. If you've modified any wires or added your own vectorization by snapping to the points or drawing in a plane, you can convert those wires or those elements to have the proper metadata for any type of encroachment later on using the third one, which basically just converts the element to a power line. And some other tips, while you're classifying or as you're classifying, there is no undo button, so make sure you save periodically. Try not to do too much at once. And just to point those saving options out, you can, if you have a tiled information, you can kick it to the original files to overwrite, or you could just create a new point cloud file. So if you just want the wires, you can hide everything except for the wires and then kick the wires out. And then also, I showed you the three methods, but really it's just kind of a foundation for you to kind of play around with and work with. Consider a hybrid approach too. Depending on your project requirements and its complexity. Feel free to mix and match method 1 and 2. For example, you can extract the wires and attachment points with method 1, and then you can follow up with the utility pole tool to get all that information associated with the pole, the tilt, the height, and any other things that you want to, pop into the attribution list. And if you're using attribution features for tagging, plan out a schema before building one. Any heavy modifications to an existing one could be done using like Notepad++ or like Notepad. That XML file that the schema is associated with can be found in the C drive, TopoDOT.gis, under the features folder.
Mike, I had a couple thoughts to tips while you were doing your examples, and
Okay.
just so I wanted to mention that if you're planning to do any encroachment or classification or classification or clearances of your wires, the wires you've created, make sure you don't modify them into, like, for example, joining all the wires together into a line string, or faceting these lines into a line string, because then you modify the actual information on the wire. So you could do that later after you do the encroachment and or clearances or anything else that is a Powerline tool, companion tool to those wires. So that's something that just to keep in mind. And one other thing that I remember that's important to know is also, like, when you're doing the method 2, where you're collecting the wires between the spans of your poles. Once you join the wires together into the attachment points, try to keep them within a similar distance from the pole to each side, so that the attachment point is going to be more accurately placed in the middle of the pole. But those are a couple of things that I know is sometimes breeze through and we don't really talk much about. But if you find yourself doing any of these things, just know that that you're going to need to have that in mind before you continue. All right. Continue, please.
Thanks, Jen. So what Jen pointed out, it kind of is in line with this key in here. So if you're not necessarily just drawing lines in, but if you are modifying the lines and you have to get them back into a compatible line, this is going to be your key in for that. So why is all this important? It allows you to essentially work remotely, with ease of scalability, and the LiDAR technology basically is going to apply to nearly all outside plant operations or applications, as well as inside plant. The extractor work is all geolocated. You're going to have improvements to productivity. It's going to lower cost, and it's going to reduce the repeat trips to the field. And you're essentially, if you compare this to kind of a traditional utility pole extraction, you're going at 10 times the speed here, or maybe even more. As I explore this sector, it seems to be pretty brutal traditionally. So you can turn a 30 poles per day operation into 300 plus, right? So that's kind of the idea behind this webinar too, is to show you that opportunity. And moving forward, what's to come? Obviously, this is in beta version, so you may not have access to this. Well, you'll have access to some of the tools, but the newer cross-section, the automated cross-section tool for the wires is not going to be available unless you get your hands on the beta. We're going to be adding to it over the next couple of weeks into the new year, so expect a little bit more improvement on that. But some topics might be calculate lowest wires, add a little bit more support for the at symbol attribution. So those were those little points that we were placing. Cylinder support for the utility pole if you want that cylinder there, and maybe some classification tools, as well as a dream tool at the end there, automatically finding the attachment points with just the utility pole alone. So we got some tricks up our sleeve. We'll have to look at that, see if it's possible, but I think you guys would really like that. All right, so if you got questions, let's go ahead and talk. Well, I guess you guys can't talk. We'll just be reading your questions and trying to answer them. But feel free to contact us by phone, email us. Definitely reach out. Okay. And
So one of the questions that we received was if the classified data can be exported to any other software like Recap or like a TrueView. And basically, whatever other software you want to export this information to, as long as they can read LAS and they could read the classified information, then it is possible. That was a question from Mike Pfaff, long time user.
Yeah, and I think we recently changed the LAS format to 1.4, so you can have more channels there for the layers or the class IDs past, what was that, 32 or something like that? Right? Any other questions we got for our audience?
So here is one that says, is there a way to show the lowest clearance from a wire on the ground or at the ground, on the ground? Sorry, is there a way to show the lowest clearance from a wire and the ground? So the tool will give you the lowest clearance and the clearance at ground. But if you're looking for something more specific, like maybe showing the text at ground level or being able to see it from top view or something like that, we can do something about that. If you're referring to the elevation point at the top of the dimension, like on the wire or the point at ground, we can do something about that too. I think the clearance tool actually allows you to export a point besides the dimension, but you can also just export the dimension or create a tag for the dimension to export either the top or the bottom or the center point of that dimension. So all of those options are possible. If you want to learn more about it, let us know. All right. Do the encroachment outputs retain minimal distance measurement information? So we have another tool that Mike didn't show, that shows actual clearance dimensions to the encroachment. So you can see the shortest distance between the encroachment and the closest point to the wire. And so this is another companion tool. We couldn't fit everything into this presentation, but we actually are going to run a poll right now just to know what you guys would be more interested in learning next, so we can follow up this webinar with maybe more of these companion tools. And so that's a great, feedback. But yes, this is possible. This is possible to be exported as well. Let me see. So there is another question: can classification be converted to RGB? Mauri, do you want to answer that? That's kind of confusing question, but you answer that one.
The classification field is stored in the LAS and the DOT files. Entry in the file. So I mean, the RGB and classification are two different fields. As far as converting classification to RGB, that's not available in TopoDOT right now. But if somebody needs that,
Great. So one more question here. So Mike showed how to classify the towers and insulators in a more manual way. Is there an automatic classification of the poles? And yes, there is an automatic classification of the poles. Once you go to the tower manager and accept all of your towers, it can create a cylinder around the pole and automatically classify those poles. But there is no solution that is automatic for any of the attached features to that pole or tower. So those insulators and whatnot will need to be classified manually within the fence, kind of like what Mike showed. So that is possible as well. Please let us know if you have any further questions, or if you want to see something else. And thank you very much. Have a good day.